Today we're going to talk about the sum of cubes. 1 cube plus 2 cube plus 3 cube all the way up to plus n cube. And I maintain that this is n times n plus 1 over 2. That happens to be the formula for the sum of 1 plus 2 plus 3 up to n. But then we square it. And this is a theorem or a fact or whatever you want to call it. And we're going to prove it. And we're going to prove it using mathematical induction. So when n equals 1, the left side tells us just to compute 1 cube, which is 1. The question is it the same as this rule here, where n is 1? I'm going to write it down exactly like here, except instead of n, I'm going to put 1. So it's, and I'll say n. It's n times n plus, didn't write 1, n plus 1 quantity squared over 2. And that's 1. One plus 1 is 2. You square it. Oh, excuse me. The 1 plus 1 is not squared. I'm being ridiculous. So it's 1 times 1 plus 1, which is 2, all over 2. And then the whole thing gets squared. But this is 2 and this is 2. 2 over 2 is 1. You square it, you still get 1. So yes, that equal sign is valid. Okay, now our induction hypothesis. We assume, oh, I have a silly error here. Of course, that was for n equals 1. Now we assume for n equals k that this rule holds. 1 cube plus 2 cube, not up to n cube, but k cube. So on the right side, instead, just like in the left side, instead of n we put k. On the right side, instead of n we put k. So it's n times n plus 1 over 2 quantity squared. But I wrote k instead of n. Now we have to show the following. Show for n equals not k but 1 more. So I need to show that 1 cube plus 2 cube up to, now instead of k, I put, or instead of n, in this rule up here, instead of n, I put k plus 1. K plus 1 cube, does it equal to n, which I write this way, times n plus 1 all over 2 squared. To simplify this, it's k plus 1 times, since 1 plus 1 is 2, it's k plus 2 over 2 all squared. That's what I want to show. So we don't know that this is true yet. So let's work on the left side. 1 cube plus 2 cube all the way up to k cube. K is less than k plus 1, so k cube will be there, plus the k plus 1 cube. Now, we know what this is equal to, or assuming it. It equals to k times k plus 1, so it's k all squared. So it's k squared, k plus 1 squared over 2 squared. And we're going to add k plus 1 cubed. But you know what? To get a common denominator, I'll multiply by 4 over 4. So now I have a 4 on the bottom. So I just have to add the numerators. Well, between this numerator and this numerator, k plus 1 squared is in common. K plus 1 squared. And what goes inside the brackets is what's left over. Well, between here, I wrote the k plus 1 squared, so I have to write down k squared plus, I didn't write down the 4 yet, but I did write down 2 factors of k plus 1 squared. They're in the front. So I have another k plus 1 left over. And this becomes k plus 1 squared times k squared, distributing the 4, plus 4k plus 4, all over 4. But the nice part of this is, what's in the second bracket is nothing more than k plus 2 squared over 4. And that whole essence, the 4 you can think of as 2 squared. Since all the factors are being squared, the k plus 1 is being squared, the k plus 2 is being squared, and the 2 is being squared, I can just put the square outside. And we are done for one reason and one reason only. We got what we were supposed to. We did show that this mess, which is what we started with, is equal to this. What's in the red equals this, which equals this mess, which is equal to this, which is equal to that, which is equal to this. That is, those two are equal. And that's exactly what I needed to show. I showed it. The theorem has been proved. Now you have a nice rule to know how to add up the first cubes, or the cubes of the first integers. 1 cube plus 3 cube up to whatever cube you want. If you like videos like this, subscribe to my channel, view it frequently, tell your friends about it, leave comments below. Thank you very much.